If all the elements of A must be the elements of set B, then A is called the subset of B and it is denoted as A is the subset of B. Let A and B are the real numbers belongs to R and A is less than B, then the set of all real numbers which lies between A and B is called an open interval. If a finite set has n elements, then the power set of A is always equal to 2 to the power of n. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Now in my previous class we have discussed regarding the subset and the properties of subsets. Now in this session I am going to discuss regarding the problems based on the subset. Now let us come to a problem. So straight away come to an exercise. Now write down all the subsets of the following set. Subset means the set of all the sets. Suppose if A and B are any two sets. Now I'll explain once again. If A and B are two sets, then A is said to be the subset of B if all the elements of A must be the elements of set B. If all the elements of A must be the elements of set B, then A is called the subset of B and it is denoted as A is the subset of B. Now what is the problem given here? Write down all the subsets of the following set. First problem, here this contains only one element. So this contains only one element. So the subset of A, the subset of A, therefore subset of A is equal to, since it contains one element A and the null set, so therefore this can also be written as the subset of A is the set which contains the element A as well as the null set. These are called the subsets of A. Now let us come to the second problem. What is the problem given? So this contains two elements. Let us consider this as A. A is equal to A comma B. The subset of A can be written as, so since it contains two elements, first element comma the second element and the two elements, the set itself and the null set. This is a subset of A is equal to A comma B. Since this contains two elements, therefore the subset of A comma B is set A, set B, set AB itself and the null set is the subset. So this is called the subset. Okay. Now let us come to the next problem. Write down all the subsets of the following sets. Subsets. Now let us come to the first problem. What is the first problem? Let us consider this as A. A is equal to 1, 2 and 3. Now the subsets of A, the subsets of A is, let us write the subsets of A. All the subsets of A. First itself is the set, the given set, then the null set and one element, first element, then 2, second element, then 3, then first two elements 1 comma 2, then 2 comma 3, then 1 comma 3. So these are all the subsets of the set. So here see 1, 2, 3, the set itself, the null set is a subset of A. 1, 2, 3, 1, 2, 2, 3 and 2, 3 and 1, 3. These are all the subsets of the given set A. So if you count, you will get, in the previous class I explained, if a set A contains n number of elements, then the number of subsets are given by 2 to the power of n. Here since it contains 3 elements, this is equal to 2 cube. 2 cube is equal to 8. So the number of subsets of A are 1, 2, 3, 4, 5, 6, 7, 8. It contains 8 subsets. Now that is called the power set. Now since, come to the next problem. If what is given, the set contains -1 comma 0 comma 1. Since this contains 3 elements, let us consider this as A is equal to -1, 0 and 1. So since there are n is equal to 3 number of elements in this set is 3. So the number of subset we are going to get is 2 to the power of n. So 2 to the power of n means 2 cube. This is nothing but 8. So definitely you will get 8 subsets. So the subset of A can be written as, first write down the set itself -1 comma 0 comma 1 and the null set, then one element -1 comma, next element 0, comma, next element 1, then repeat first 2, minus 1, comma 0, then 0, comma 1, and the last one is minus 1, comma 1. So this is called the subset. See, how many subsets are there? 1, 2, 3, 4, 5, 6, 7, 8. So this contains 8 subsets. So these are the subsets of the given set. Hope you followed. Now let us come to a next type problem. How many elements has P of A if A has a null set? If A is a null set, then the power set of A. Here P of A has only one element. How many elements has P of A? Since P of A has only one element, that is a null set. P of A has only one element, that is a null set. So therefore P of A is equal to a null set. That's all. P of A is equal to a null set. That's it. Okay. Now let us come to the next problem. Yes, this is very important. If a finite set has n elements, then prove that the power set of A has 2 to the power of n elements. This is a theorem. Suppose if a set has n elements, then power set of A is always equal to 2 to the power of n. This is to be proved. So if a set has n elements, then the power set of A has 2 to the power of n elements. Now listen to me. So what is given? Since a set has how many elements? A finite set has n elements. Given the set A has n elements, since the set has n elements, there may be no subset or one subset, two subsets, three subsets, etc. n subsets. So this can be written as, that is no element nc0, one element nc1, two elements nc2, etc. n element ncn. Now therefore the total number of subsets, total number of subsets of A can be written as the sum of these nc0 plus nc1 plus nc2, etc. plus ncn. Right. Since using binomial theorem, we know the expression for 1 plus x to the power of n. Since the binomial expansion of 1 plus x to the power of n is nc0 plus nc1x plus nc2x square plus etc. plus ncn. This is the binomial expansion of this equation. Now if you observe carefully, this can be written as, the total number of subsets of this can be written as 1 plus x to the power of n. Now put x is equal to 1. So if you put x is equal to 1, then this becomes 1 plus 1 to the power of n is 2 to the power of n. So therefore the number of subsets of n elements of a set A is 2 to the power of n. So therefore this is denoted as P of A, that is called the power set. The power set of a set A is always equal to 2 to the power of n. So the power set is 2 to the power of n. That's all. Okay, hope you followed. Listen to me. Let the set A has n elements, then the number of subsets, or the subset may have no element, one element, two element, or three elements. So that can be written as nc0, nc1, nc2, etc. ncn. The total number of subsets can be written as nc0 plus nc1 plus nc2 plus etc. ncn. Now we know the binomial expansion of 1 plus x to the power of n is nc0 plus nc1x plus nc2x square plus etc. ncn. Suppose if you put x is equal to 1, then this becomes 1 plus 1 to the power of n is equal to nc0 plus nc1 into 1 is nc1 plus nc2 plus etc. plus ncn. So that is nothing but nc0 plus nc1 plus nc2 plus etc. ncn is nothing but 1 plus x to the power of n is 1 plus 1 to the power of n. That's equal to 2 to the power of n. Therefore the power set of A is 2 to the power of n. P of A is equal to 2 to the power of n. That means If a finite set has n elements, then the power set of A is always equal to 2 to the power of n. This is very important concept. Now let us come to this problem. If n of A is equal to 3, then find the power set. The first problem, what is the problem? The number of elements in the set is 3. The set A contains 3 elements, then the power set n of P of A, number of elements in the power set. Since this contains 3 elements, according to the definition, n of P of A is equal to 2 to the power of n. If a set A contains n number of elements, then the power set of A is P of A is equal to 2 to the power of n. Number of elements in the power set is 2 to the power of n. So here n of P of A is equal to 2 to the power of 3. 2 cube is nothing but 8. So therefore n of P of A is equal to 8. This contains 8 elements is the first answer. Okay. Now let us come to the second one. So if n of P of A is equal to 32. So the power set contains 32 elements. Power set is equal to 32. If number of elements, number of power set, if n of P of A is equal to 32, then find the value of A where A is a finite set. Very simple. So this 32 can be written as 2 to the power of 5. 2 into 2 into 2 into 2 into 2. 2 to the 4, 4 to the 8 to the 16 to the 32. So this is n of P of A is equal to 2 to the power of 5. Since we know n of P of A is equal to 2 to the power of n. So this is 2 to the power of n, means therefore the value of n is equal to 5. That's all. Very simple. See, the number of subsets are 32. So therefore n of P of A is equal to 32 can be written as 2 to the power of 5. Since we know if a set A contains n elements, then the power set of A is n of P of A is equal to 2 to the power of n. So equate this to the 2 to the power of n. 2 raised to n is equal to 2 to the power of 5. Therefore n is equal to 5. N is equal to 5. The number of elements of the set is 5 elements. That's it. Very important problem this is. Okay. Hope you followed. Now let us come to the next problem. Now what is the problem given? This is also very important. Two finites. How many are there? There are two finite sets have m and n elements. The total number of subsets of the first set is 40 less than the total number of the subset of the second set. Find the values of m and n. This is also an important problem for 3 marks. Now what is given here? Two sets. Let us consider two sets. Let A and B be the two sets. Let A and B are two sets. Now the number of elements in set A, the number of elements are m and n. So therefore here P of A, the number of elements, so n of A here, n of A is equal to m and n of B is equal to n. So here let us consider two sets A and B. The number of elements in the sets are given. The number of elements of the set A is m and the number of elements of the set B is n. Now therefore find out the subset. So n of P of A, so the power set of A is equal to 2 to the power of m, and n of P of B, the power set of B is equal to 2 to the power of n, right? Because if a set A contains n number of elements, then the power set is 2 to the power of n. Since the set A contains m number of elements, therefore it is equal to 2 to the power of m, and B contains n elements, therefore the power set is equal to 2 to the power of n. This is the given condition. Now listen, what is the given condition? This is the given statement, and given condition is, what is the total number of subsets of the first set. The total number of the subsets of the first set is 40 less than the total number of the subsets of the second. Given that the total number of subsets n of P of A is 40 less than, means 40 minus number of subsets of B. This is the given condition. So n of P of A is equal to 40 minus n of p of b. This is the given condition. Okay. Now, this can be written as, what is n of p of a? 2 to the power of m is equal to 40 minus 2 to the power of m. Transfer this. 2 to the power of m plus 2 to the power of n is equal to 40. Now, this can be written as 2 to the power of m plus 2 to the power of n can be written as, split this 40. 40 can be splitted as 32 plus 8. So, this is 2 to the power of m plus 2 to the power of n is equal to 32 can be written as 2 to the power of 5. 8 can be written as 2 to the power of 3. 2 raised to m plus 2 raised to n is equal to 2 to the power of 5 plus 2 to the power of 3. Therefore, here m is equal to 5 and n is equal to 3. Or we can also write like this, m is equal to 3 and n is equal to 5. So, 5. N is equal to 5. So, therefore, we can write m is equal to 5 or n is equal to 5 or m is equal to 3 and n is equal to 3 or n is equal to 5. So, 3 and 5 or 5 and 3 are the values of m and n. That's it. Okay. Hope you followed this. This is the actual answer for the given problem. Okay. Now, let us come to the next problem. Now, let us come to the next concept, intervals of a subset of R. This is very important. The intervals as subsets of R, intervals as the subsets. So, what are the intervals we are going to study? Closed interval, open interval, off closed, off open and off, that is semi, off closed and off open intervals. So, what are the conditions for those intervals that we are going to study here? Now, let us consider A and B. Let A comma B belongs to the set of real numbers and A is less than B. If A is less than B is the condition. Let A and B are the real numbers belongs to R and A is less than B. Then the set of all real numbers which lies between A and B is called an open interval. That is, if A and B are any two elements of the set of all, that is real numbers, if A is less than B, then the set of all real numbers y such that A less than y less than B means all the values of y which lies between A and B is called an open interval. The values of y which lies between A and B, all the values of y which lies between A and B is called an open interval. The open interval is denoted as A comma B. That is nothing but a set y such that A less than y less than B. All the values of y which lies between A and B is called an open interval. See here. Suppose if A and B are any two elements of the set, all the values which lies between A and B, in between A and B, that is all the values of y which lies between A and B comes under the set that is called an open interval. Now, here in an open interval, all the points between A and B belongs to the open interval A and B, but A and B themselves, these two do not, these A and B are not included in the interval. So, A and B themselves do not belongs to the interval. So, all the values which lies between A and B comes under the open interval. So, in an open interval, A comma B, x such that A less than x less than B or A less than y less than all the values of x which lies between A and B comes under the open interval. Now, let us consider an example. For example, 3, 7. Now, what are the elements of 3? You can write the elements first: 3, 4, 5, 6 and 7. So, in between these 3 and 7 are 4, 5 and 7. The elements of this 3, 4 is a set which contains 4, 5 and 6. This is the open interval. That means all the values of x which lies between 3 and 7, which lies between 3 and 7 is 4, 5 and 7 on the set of real numbers. This is an example for an open. So, in general, the open interval is denoted as A comma B, small bracket A comma B, such that x such that a less than x less than b. That means all the values of x which lies between a and b comes under the open interval excluding a and b. So this is the symbolic representation of an open interval which lies between a and b. Now let us come to the next one, the closed interval. Next one is the closed interval. Now the interval which contains the endpoints also, a interval which contains all the values including the endpoints comes under a interval that is called a closed interval, and it is denoted as a comma b, big bracket, a comma b. So if a and b belongs to the set of real numbers, then the closed interval a comma b is given by x such that a less than or equal to x less than or equal to b. That is, x lies between a and b including a and b. So that is the closed interval a comma b is nothing but x such that a less than or equal to x less than or equal to b, or y such that a less than or equal to y less than or equal to b. All the values of which lies between a and b including a and b comes under the interval that is called as the closed interval. So the closed interval of a and b is a comma b is equal to x such that a less than or equal to x less than or equal to b. That is representation of a closed interval. All the elements which lies between a and b including a and b is called the closed interval. Let us consider, for example, 2, 5. So on the real number, so if 2, the closed interval of 2 and 5, this is nothing but all the elements 2, 3, 4 and 5. So therefore the set which contains all the elements 2, 3, 4, 5 including 2 and 5 and all the elements, therefore this is an example for a closed interval, right? Now let us come to the next one. Suppose if it is off closed and off open, or off open and off closed, that is when we have interval closed at one end and open on the other end, that is, suppose if it is like this, AB, the interval AB, X such that A less than or equal to X less than B is an open interval from A to B including A but excluding B. This is off open and off closed. Off open and off closed. So this is an open interval from A to B including A but excluding B. Similarly, A comma B, X such that A less than X less than or equal to B is an open interval from A to B including B but excluding A. So here A is included, B is excluded, whereas here A is excluded and B is included. So denoted as the value of x which lies between a less than or equal to x less than or equal to b comes under this interval, and x less than a, that is x. So x where a less than x less than or equal to b comes under the interval. So this is called off closed and off open, or off open and off closed interval. That is called as a semi open and semi closed interval. This is called a semi open and semi closed interval is denoted as a comma b such that x such that a less than or equal to x less than or equal to b. So here it is open on this a, all the elements of a and the elements which lies between b. So example for this I will give. So a comma b, this is a representation of a semi open and semi closed interval. Here semi open and semi closed interval is nothing but a comma b, that is x such that a less than x less than or equal to b. So here b is included, a is excluded. So here a is included, b is excluded. So that is a less than or equal to x less than or b including a all the elements except b. Here including b all the elements except a comes under this semi open and semi closed interval a comma b such that x such that a less than x less than or equal to b. Here a comma b is equal to x such that a less than or equal to x less than or equal to b. These are the intervals. So open interval, closed interval, semi open and semi closed interval, or semi open and semi closed interval. These are very important concept. Now let us take few problems based on these intervals. So these notations provides an alternative way of designating the subsets of the sets of real numbers. So for example, let us consider if A is equal to minus 3 comma 5 and B is equal to minus 7 comma 9. So the subsets, the open set and the closed set. So suppose if a set contains 0 to infinity defines a set of non-negative real numbers, while the set minus infinity to 0 defines a set of negative real numbers. So this is 0 to infinity represents the set of all positive, set of all non-negative real numbers, whereas this set minus infinity to 0 will represent the set of all negative real numbers. Suppose if the set contains minus infinity comma infinity, the set minus infinity comma infinity describes the set of real numbers in relation to a line extending from minus infinity to plus infinity. So the set minus infinity comma infinity defines the set of all real numbers in the relation of to a line extending from minus infinity to the plus infinity. So on the real number of line, on the real number line, the various types of intervals can be described above as like this, that is open interval A comma B, closed interval A comma B, off closed and off open, off open and off closed, semi open and semi closed. So can be denoted like this. These are the representation of a open interval, closed interval, off open and off closed and off open interval. So this contains infinitely many points. Okay, let us come to the example first. The set X such that X belongs to R and minus 5 less than X less than or equal to 5. This can be written as, the set can be written as, this is equal to, here what is this element, minus 5 comma, this is off closed and off open interval, off open and off closed. This can be written as minus 5 comma 7. This is big bracket. So minus 5 comma 7 of semi open and semi closed interval, minus 5 comma 7. Okay, all the values which lies between minus 5 and up to 7 comes under this. Now the second one, so write this interval in the set builder form. X belongs to R minus 5 less than X less than 7 can be written in the set builder form as minus 5 comma 7. Now let us consider one more interval. Suppose if the interval minus 3 comma 5 can be written in the set builder form as, what is here given? This is nothing but X such that X belongs to real number and minus 3 is less than or equal to X less than 5. This is the set builder form for the interval. Minus 3 less than or equal to X less than 5. Now the number B minus A is called the length of any interval A comma B. So any interval, either it may be a closed interval or open interval, semi closed, semi open, the difference between B and A, B minus A will give the length, is called the length of the interval. Now let us take an example based on the exercise. Now exercise problems based on these intervals. Now first one, write the following as an intervals. So this can be written as, what is given, X such that X belongs to R minus 4 less than X less than 6. This is nothing but off closed and off open, minus 4 comma 6. Minus 4 comma 6. Whereas this one, the second one is X such that X belongs to real numbers, minus 12 less than X less than minus 12. This is nothing but the open interval, minus 12 comma minus 10. So here the values which lies between minus 12 and minus 10 comes under this interval. Here the values of minus 4 less than X less than or equal to 6. Therefore we are using off closed and off open interval. Let us come to the next problem. Third one, X such that X belongs to R and 0 less than or equal to X less than 7. So therefore this can be written as, here 0 less than or equal to closed interval 0 comma 7. So again this is off closed and open interval, that is 0 comma 7. Whereas this one, this implies X such that X belongs to R, 3 less than or equal to X less than or equal to 4 means this is 3 comma 4. This is the closed interval. Suppose if it is like this, 3 less than or equal to X less than 4 means this can be written as the closed and of 3 comma 4. This is the small bracket, right? So these are the examples. Now let us come to the next problem. Write the following intervals in the set builder form. Set builder form. So what is given here? The elements are -3 comma 0. Therefore this can be written as, let us consider a is equal to x such that x belongs to the real number and -3 less than x less than 0. -3 less than x less than 0. This is the open interval. Here -3 comma 0 is nothing but an open interval. A is equal to x such that x belongs to the real number such that -3 less than x less than 0. Come to this problem. What is given here? B is equal to 6 comma 12. This is closed interval. Now let us define the set x such that x belongs to real numbers and 6 less than or equal to x less than or equal to 12. That's all. Okay. Suppose if it is like this. Suppose if it is 6 comma 12, we can write it as x such that x belongs to real numbers, 6 less than x less than 12. See the difference, less than or equal to or less than. Now let us come to the next problem. Here, write the following intervals in the set builder form. So let us define this as C, x such that x belongs to real numbers and here this is off closed and off open, 6 less than x less than or equal to 12. 6 less than x or less than or equal to 12. Now let us come to this. Let us define this as D. D is equal to x such that x belongs to real numbers and -23 less than or equal to x less than 5. That's all. If it is like this, if the interval is 6 comma 12 open interval, then I can write the formula for this as x such that x belongs to real numbers, 6 less than x less than 12. Suppose if it is like this, suppose if this is -23 comma -5 means I can write this as x such that x belongs to real numbers, -23 less than or equal to x less than or equal to 5. See the difference between these two. Okay, this is how we are going to represent. Now let us come to the next set of problems. Given the set A is equal to 1, 3, 5, B is equal to 2, 4, 6 and C is equal to 0, 2, 4, 6, 8. Which of the following may considered as the universal set or sets for all the 3 A, B and C? Now the universal set is nothing but set of all the elements. Now write down the union of all the elements. Universal set of, what is set A contains? A contains 1. So first it is 0 is there. 0, 1, 2, 2, 0, 1, 2, 3. Then we have 4 also. 4 also. Then 5. Then we have 6. Then 8. So these are the elements we have. 0, 1, 2, 3, 4, 5, 6 and 8. These elements we have. So given 3 sets, which of the following may consider as universal set for all the 3 sets A, B and C? See here, this contains, so 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This contains null set and this contains 1 to 8. Now among these we have to check which of the following is an universal set for this. Now see here, in the first set we have 0, 1, 2, 3, 5 but 8 is not there. This is not an universal set, not an universal set. So if you consider this here, 0 is not, this is also not. So therefore this is the universal set. Therefore the universal set is third option. This is the universal set for the given set which contains 0 to 10. Okay. These are few problems based on the sets and the subsets. Okay. That's all for today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.